All right, we're going to do problems 1 through 5 here on review day number 11. And the first one is simple enough. We're just integrating x squared over 4. If it helps you, you can pull that 1/4 out first and then integrate x squared. The integral of x squared is x cubed over 3. So it's just a matter of multiplying 4 times 3 and getting 1/12. And there's b. So easy one to start with here. Second one asks what's the equation of tangent to cosine at pi over 2. So anytime we see line tangent or tangent line, we're thinking point and slope. So the x coordinate for our point is pi over 2. To get the y coordinate, we put that in. Cosine of pi over 2 is 0. All right, and then as far as slope goes, we take the derivative. So dy dx would be negative sine. And we put pi over 2 into that. Sine of pi over 2 is 1, taking the opposite, so negative 1. So constructing it would give us y minus 0 equals slope times x minus pi over 2. And when you look at your options, they've distributed the negative 1. And so if we multiply, we'll get negative x plus pi over 2. And that's option C. All right, so again, not too bad, just got to be a little careful with some of the algebra in there. Okay. Number 3 here asked us to find the derivative of 2 sine square root of x squared. So we're going to do the outer function first, the squared. So that comes down, multiplies the 2. We'll have 4 times, leave the inside alone, to the first power, times the derivative of the next function, which is sine. So the derivative of sine would be cosine. Leave the inside alone. Then times the derivative of this, which would be 1/2 x to the negative 1/2. Right? So 4 times the half would give us 2. We'd have sine square root of x, cosine square root of x, and then this x to the negative 1/2 would flip down and be on the bottom. So D is our choice on that one. All right. Number 4 gives us an integral, and it's definitely pretty complicated looking here. It's going to be a u sub, and well, although it'd be tempting to put the whole bottom as the u, we're going to start with the inner function. We've got x cubed plus 3x minus 5 inside of the cube, so u is going to equal x cubed plus 3x minus 5. du equals 3x squared plus 3 dx. All right, so du over 3x squared plus 3 equals dx. So now when we come over here, we're going to have the integral of x squared plus 1 over u times du over, and then this, if we pull a 3 out, would be 3 times x squared plus 1. The x squared plus 1's cancel. We can pull the 1/3 out. We get 1/3 over 1 over u du, which gives us 1/3 times the natural log. Oh, I'm sorry. Forgive me there. I got silly here. We forgot the cubed on this. So this actually should be 1 over u cubed. I'm looking at my choices and see no natural logs. I got a little nervous. This is going to be 1/3 times the integral of u to the negative 3, which when we integrate that becomes u to the negative 2 over negative 2. That's going to work out a lot better. So this becomes negative 1/6, and then we get 1 over u squared, so we put this back in, plus c. And we look over here, we got 2 negative 1/6. This one is over the du squared. This one's got the u squared, so D is our choice on that one. All right, then our last one here. It says we got a function given to this. When is it concave up? It will be concave up when its second derivative is positive. So we'll take the first derivative, 12x squared minus 4x cubed, and then take the second derivative, 24x minus 12x squared. We're going to set that equal to 0. So I can pull a 12 and an x out. I'm going to get 2 minus x left over. So that's at x equals 0 and at 2. So now what I do is test those out, and I want to see when is that second derivative positive. So if I were to put a negative value, say -1 in here, I'm going to get negative minus, and this will stay 12, so that'll be a negative value before 0, so we're concave down before 0. If I try something in between, say +1, I'm going to get 24 minus 12, that's a positive, so between 0 and 2 for sure. And if I try something afterwards, I'm going to get a negative, so that's down. So the only place that we're concave up is right between 0 and 2, and that was C. All right, so not too bad on that one.